Okay, so learning to graph tangent, cotangent, secant, cosecant. I'm going to tell you this, is that it really follows the same rules for the transformations that it does the other stuff. Okay? So, in this case for number 3, what's the only thing that changes here for tangent? What's that, everybody? The period? Yeah, very good. It's the period. So only the period is affected here. So what's the period typically of tangent? It's not 2 pi, but it's pi. And it's divided by that b term, okay? Which is actually right up here. So for this problem, the period is going to be pi over, what's the b term? Well, it's not 2. It's actually 1/2. Right? Is it the same thing as tangent is 1/2 x? It's the same thing? So the period is actually 2 pi. So I'm going to start graphing at my favorite number, 0, and I'm going to end at 2 pi. Because all I do is I just graph one period. I don't graph more than that unless it tells me you must graph 2 periods. Got it? So what's smack dab between 0 and 2 pi? Pi, we did this yesterday, so this shouldn't be anything new. Okay, and then I'm just going to say, I usually mark off the height here, which is 1. I know there's no actual amplitude, but it's a vertical stretch, really, so nothing's stretching, so I'm just going to mark off a 1. So here are the important points. So for tangent, what's at 0? What's tangent at 0? 0. Okay, looking at our little graph that we just did, what's the next thing in your table? Alright, this was an asymptote, right? And then we had 2 pi, correct? If you're looking at your graph that we just did, this is what we had. Now what goes in between? Correct, but remember, we're stretching it. Remember, we changed the period here. We changed the period of this one. Okay? So we said 0, the middle one is the asymptote, and the end one is 0. This is me ignoring what these numbers are down here. So I'm going to go with 0, middle one is asymptote, and then the end one is going to be 0. Hey, in between, isn't it increasing to start, tangent? So it actually is going to go to 1. Okay? Bless you. And then this bottom one, or this one at 3 pi over 2 is going to go to -1. I probably should mark that off as -1. So this is what 1 period looks like, and it goes up and up forever. And it is going, and it from this way, it's also increasing. So this is 1 period of tangent. Again, I always have you graph 5 important points. So for tangent, the important points are on, above, can't do it, below, on. Remember, like for cosine, I was like, it's above, on, below, on, above, and we were like, yay, that was so fun. No one said, yay, that was so fun? And then this one's just going to be on, above, can't do it, below, on. This is what all tangents look like. What's going to change, though, for tangents? However high this number is, okay? And then whatever the period is, so these numbers right here can change. But this is the shape. Every time you graph tangent, this is the shape. Got it? This is the shape. If it asks you to graph 2 periods, you just keep going. Alright? You would just keep going over here, do the same thing. Whee! Then asymptote, and you come down. Okay? It's cotangent. I only have 2 transformations here. What are they? Amplitude. So instead of marking off 1, I'm going to mark off A. And then what else changes? Period. So what's my period going to be in this one? So period is going to equal to pi over 1/3. So I'm going to get 3 pi. So I'm going to mark off 3 pi. What's smack dab between 0 and 3 pi? Someone said 1.5 pi, I think. 3 halves pi, or 3 pi over 2. What's in between that? 3 pi over 4. And then 5 pi over 4. Okay, so for cotangent, at 0, what happens? You can look at your other little sheet if you want to. It's what? Asymptote. Right, at 0 you get an asymptote? And our other endpoint is also an asymptote. Smack dab in the middle is what? 0. I didn't space this out very nicely. And then the first tick mark is at above, below, 0, asymptote. Which one is it? It's above. And the last one we didn't mark off is going to be below. So tangent and cotangent are almost the same. Okay? The only thing we're doing is we're flipping zeros. Zeros are asymptotes. Asymptotes are zeros. That's the only thing we're changing. Okay? So zeros are asymptotes. Asymptotes are zeros. And then I'm going to go ahead and sketch this little guy right here. Here he is. There is cotangent. Stop Snapchatting and start learning. I don't think you are.
I just finished the graph.
Okay, let's combine everything we did today so far with what we did yesterday. We'll start shifting this thing around. So let's do this one right here. 3 tangent 1/2 x plus 4. What transformations do I have with moving it up, down, left, or right? Or, yeah. I'm doing what to it? I'm up 4. So I'm going to start at, here's my little transverse axis right here. I'm starting at 4. How much above am I going to go? 3 above, which gives me what number? And how much more below? Not to scale, whatever. What's my period? It's actually going to be 2 pi again. Well, that's wonderful. So again, I'm going to have that, I'm going to go out 2 pi, and we're going to get pi, we're going to get pi over 2, we're going to get 3 pi over 2. Alright. So this one is on, above, asymptote, below, on. It's the exact same pattern as this one right here. It's just everything is shifted up. That's why I drew my transverse axis. I think it's easier to draw a transverse axis. So here we go. Whee! Whee! So fun. How are we on tangent, cotangent? We're good? We'll get a chance to practice this, don't worry. See, we're almost done with the notes. Look, we're only 10 minutes. Got one problem left. Okay, so these are just the parent functions of secant, cosecant, and secant. We'll just go ahead and hit it hard right here. Okay? So what I'm going to do is I'm going to first, for secant, I'm actually going to sketch, what's secant sibling? Cosine. I'm going to sketch cosine. Okay? And I'm going to go from there, and you'll see what I'm doing. let's pretend this is cosine, and let's go through it. What's the period? It's 2 pi over 2. Why is it over 2? Because that 2's in front, so I'm going to get pi. So I'm going to go out 2. Pi. Middle of that's pi over 2. Am I going too fast? Good. How high do I go? I go up to 3. How low do I go? -3. I'm gonna use my pencil here, very lightly sketch what cosine is. Because am I actually graphing cosine?
No.
Cosine is just my helper to help me figure out what's going on. So if I were to graph cosine, I would go above, on, below, on, above. And this is all from the lesson last time. So I'm going to do just like dots like this so I know this is not my actual graph. Okay? So secant is the reciprocal of cosine, which means that we actually have to flip everything. Okay? What happens when we flip a 0? What does it become?
Same thing.
No. When you flip 1, it's the same thing. It's undefined. So I'm going to draw my asymptotes at my zeros for cosine. Okay? Because when cosine is 0, secant is undefined. That means it's an asymptote. It's still right here at 3. It's still right here at -3. And it's still here at, again, +3. Those are still there. Okay? But instead of going down, a reciprocal is actually going to reverse it. So instead of going down, it's going to go up. Okay? So instead of this being a little valley right here, I have to make a hill. And same thing with this one right here. Okay, I did not do a cosecant example. Do you want me to do one? Yes? Want me to do the parent function, or want me to mess around with it a little bit? Mess around? Alright, how am I going to mess around with it? You tell me. Shift it left? And how about that's it? We'll just shift it left and we'll go from there. Okay? So let's make this secant. I'm going to go up here to 8. Wait, no. Yeah, no, I need to do a cosecant. Sorry. Let's go up to 7 right here. Let's make this x minus x minus pi over 4. Is that good? So what am I going to kind of sort of sketch? Let's kind of sort of sketch sine. Let's do it. So to sketch sine, I'm not starting at 0, but I'm starting at... I almost did the same thing I did in the homework. Starting at pi over 4. Okay? Why am I starting at pi over 4? Because it's going right. This one's going right. Pi over 4. Okay. What's my period? It's 2 pi. There's no number in front of that x, so it's 2 pi over 1, which is going to give me 2 pi. So what's 2 pi away from pi over 4? 2 pi plus pi over 4. 9 pi over 4. Oh, that's very sexy. It says she on my desk. Not a she. I'm a boy. Hey, what's smack dab in between? Add these, divide by 2. What is it? 5 pi over 4? What's here and here? 3 pi over 4 and 7 pi over 4. Am I going? 1 and negative 1. So for sine, I'm starting where? I start on, and then I go up, on, below, on. So again, a little bit of a sketchy poo here. What do I do at all my zeros here? They're all asymptotes. Okay, so at 3 pi over 4, what am I doing there? Having it go up. And then this one I'm having go down. We good?